Okay, so this is Unit 3B, Part 3. And for number 9, it says, oh yes, what's the order of magnitude? And by the way, the order of magnitude, see page 147. If it's units of 1 or 10 or 100, each one of those is an order of magnitude, or 1,000 or 10,000. So, what's the order of magnitude of money spent on food each year by Americans? So this is just an estimate. And so we've got approximately 300 million Americans. So 300 times 10 to the 6. Actually, there's more than that. There's about 325 million. And I'm rounding here, by the way, rounding. And then let's say each person spends $10 a day. So that's 300 times 10 to the 6 persons times $10 per person days, and times, and I rounded the number of days, 400 days per year. So when we carry out that product upstairs, we get 12 times 10 to the 11th. Writing this in scientific notation, we move the decimal over once to the left, make this value smaller, so we have to make this larger by a factor of 10. And I get 1.2 times 10 to the 12th. Well, that's the order of magnitude is trillions of dollars. So C is what we're talking about. For number 10, oh, I see. The distance from the Earth to the Sun is quite large, and how long would it take a rocket traveling at a given speed to reach the Sun? And I get, using dimensional analysis and writing the distance to the moon and the rate of speed, and when we divide, we invert and multiply, so the miles go downstairs, the hours upstairs, and now the miles divide out. We're left with hours, and when we carry out this quotient, we get 3.2 times 10 to the 4th hours. So that's D. D. And for number 11, oh, we had to write the scale factor of 6 inches per 7 miles. And 6 inches per 7 miles. Now, you know you have the scale factor when all the units divide out. So we've got 6 inches per 7 miles. There's 12 inches in a foot, 5,280 feet in a mile. The feet divide out, the miles divide out, the inches divide out, and what we're left with is 1 over 73,920, which is A. And for the last one, oh yeah, you are constructing a scale model solar system using a scale ratio of 1 to 10 billion in your scale model. What will be the diameter of Jupiter in meters? The diameter of Jupiter in meters is 143,000 kilometers. And I'll convert that to meters, and there's 1,000 meters per kilometer. The kilometers divide out. And now we'll multiply that times the scale factor. We're multiplying the numerator. What we get is 1.43 times 10 to the 8th meters. And the denominator, 10 times 10 to the 9th, is 1 times 10 to the 10th. Well, 1.43 then, that's going to be 1.43 times 10 to the negative 2, which is 0.0143 meters, which corresponds to selection A. And we are done.